Thank you.
Thanks very much, Fabio. My name is Mike. I'm glad to be here today with Erminio, who's going to share his screen, so I'll be asking him to change slides. It's great to be here. I want to, just talk a little bit about this project that we're doing today. I think a lot of people here are probably very familiar with the work that EHRI does, but because some of you may not be, for some of the newcomers, I just want to talk a little bit about the background of this project, its raison d'etre, so on. So this is a little introduction to the EHRI Portal and the data that we're talking about. So if we go to the next slide, and the next slide. So as it probably goes without saying, the Holocaust left behind a tremendous amount of documentary evidence of many kinds. Just to show a few examples here, the photo you see on the left is pictures of the barracks where Kaserne de Sana Memorial now exists in Mechelen in Belgium. And there, in between 1942 and 1944, about 26,000 Jews and Roma were deported to Auschwitz. In the photo in the middle, you can see a display at the museum, Kaserne de Sana, where of some of the personal effects, the artifacts and documentation that were confiscated from the victims. And on the right, the photo you see is some of the transport lists that were produced by the perpetrators. And now if we go on to the next slide, this is just a sort of a brief touch on some of the kind of documentation that now exists in archives all over the world, and that has been described, catalogued and organized, and in some cases, though perhaps not as many cases as we'd like, made available online for historians and researchers and so on. In some cases, that material will actually be available to view. In some cases, it's just descriptions of it, so people know what the information is. Now, if we go on to the next slide, so a big caveat there, because the Holocaust is perhaps unique because of the complexity of trying to understand this archival landscape on a sort of top-down, global, transnational scale. There are many reasons for this. A big reason is just the sheer size of the geographical area on which the events took place, the number of different administrations and languages involved. A big factor is the intentional destruction of evidence by the perpetrators. And another, of course, is just the chaos of the war, the dislocation of people, administrative bodies, and so on. And of course, a lot of the migration of survivors and people involved and witnesses after the war. And this results in, as we've said, a very fragmented archival landscape, especially for those who are trying to study the Holocaust on a transnational, global basis. So, beg your pardon. Now on to the next slide. So here's just a quick overview. If you try and, if you're researching it, you have to go to many different websites. We have examples here of material you can find online from Kaserne de Sana, the Wiener Holocaust Library here in the UK, the United States Holocaust Memorial Museum, and so on, many different archives and institutions. Next slide, please. And so EHRI was begun in 2010, and one of its missions was to try and make it easier for researchers to explore this landscape of archival material and evidence on a transnational basis by making this information easier to find. And the way we do that is by integrating metadata, descriptions of this material produced by archivists into one place. And that place, if we go on to the next slide, is called the EHRI Portal. And this is a website that uses standards from the International Council on Archives, the ICA, and it offers, as I've said, a central entry point to explore Holocaust-related archival material and to discover information about the institutions that hold this material. Next slide, please. And This is sort of how the same information that we saw earlier would look in sort of a uniform way in the EHRI portal, which is, as I say, searchable at one point and integrated using the same standards. So if we go on to the next slide. The slight problem with this scheme of sort of integrating metadata from hundreds of different institutions, there are over 2,300 institutions listed on the EHRI portal, and about, I think, 800 of those we have actual metadata about their collections. This is a very complex process, and it's not a process you just do once, because although the material is sort of changing at a limited rate, the way that institutions digitize their material, the way they present it online and so on, is constantly evolving. So to integrate this metadata into one place is a challenge, and one that you're constantly sort of pedaling to keep up with. So what we're doing in this thing today is to look forward to technologies that may be able to improve this process, to mitigate the difficulty in integrating this information. And that technology involves the semantic web, and Arminio is going to take over from me now and explain a bit about what that is and why you would use it.
Oh, thank you, Mike, for the introduction. So I'm going to explain what is the semantic web, also known as in the cultural heritage as link open data. And from this explanation, then we will be able to understand how we can apply the semantic web to the EHRI portal case. So first, a recap on the web. So the web is based on web pages hosted in servers. The links let users navigate to other pages. It is strongly standardized, so irrespective of the operating system that we use or the browser that we are using, we are seeing the same representation of the web. And that's thank you to the standards. Then we have an identification of each resource on the network. So we can say that is distributed, is interlinked, is based on agreed standards, and we use unambiguous identifiers to identify each resource of the network. But there is a caveat for that, is that the computers are not able to understand its content. So you may think that, well, we have web pages and these are rendered by the browsers, but these are mainly designed with natural language. So the natural language is only able to be comprehended by humans, but not by computers, letting alone, let's say, artificial intelligence technologies that we see right now. But why unambiguous identifiers and how the web can play a role? So if I pose this question, who is the man in the picture? Some of you will say Barack Obama, some others will say President Obama, and a third group maybe will say Barack Hussein Obama II. And the thing is that the three answers are correct. So we have three different ways to mention a person. So we may think that we have a problem, but not really, because we normally use these unambiguous identifiers to identify entities on the web. This is called internationalized resource identifiers, IRIs, and they serve to unambiguously identify a resource, and we use them every day on the web. So if I go here, and let me know if you cannot see this screen, we can see the representation of this entity of Barack Obama and the associated information. The thing is that if we see the source code of this web, then we can see the HTML code. And even though this is processed by a machine, the browser, you can see that, for example, in these parts, we have natural language, and this is impossible or really difficult to process by a machine. So coming back to the presentation, so how computers can process this information. So the HTTP protocol offers a feature called content negotiation that allows clients to ask for different formats. So for the same resource, we can get different representations. So we can get the HTML representation, but we can also get a structured content. So I'm gonna do another demo for that. So I'm gonna open this application. This application allows me to do manual requests to the server. So I will be able to tune the request as I want. So it's taking a little bit to load. I don't know why. So I think that I might have to skip this thing. Now it is working. Sorry for that. So I will make this bigger. So as you can see, I am using the same array. Now I'm gonna uncheck this option. And if I send a request, then the response will be the same HTML that we have seen in the browser. But if now I ask another format, and I do that by using this header, you will see how the server will return another response. And this is a more structured content that computers are more able to process. So now coming back to the presentation. Oops. So the key idea is to offer a machine processable version of the web that is based on standards and interlinked datasets. And for that, it is based on the web. So we can offer a distributed way of processing the information. We have also the ambiguous identifiers using EHRI. And then this content negotiation allows two versions of the web. One that we will call the syntactic web, that is meant for users. Another that is the semantic web, that is for computers to be processed. Now, to understand how we apply that to the EHRI portal, I'm gonna do a little explanation of the semantic web data model and the associated technologies. So data in the semantic web is modeled in a graph, and the minimum statement that we can say about in a graph is a triple. And the triple is composed of a subject, a predicate, and an object. In this case, we have subject myself that knows Mike Bryant. But the problem with this statement right now, as it is that these two need to be EHRI. Well, to be fair, only the subject needs to be an EHRI because the object can also be a literal, like a test or a number or things like that. But for the sake of the example, let's say that both of them have to be EHRI. So now this is the same graph, the same triple, sorry, but with an ambiguous identifier. So in my case, I have used my own web page. For Mike Bryant, I have used Mike Bryant entry in the NIOD's web page. So in this way, we can unambiguously identify both entities, but then we have another problem, and that is that the predicate needs to be an EHRI too. And remember, standards are a key element of this model. So which standards for predicates? So we have controlled vocabularies that we use them quite often in cultural heritage. They define the semantics of the relations, and they are standardized or at least agreed upon. And then we have ontologies that cover the same aspects of vocabularies, but they can contain more complex knowledge about the relations. And we normally call that axioms. And they also define some resources and concepts to be used then in the statements. And the good thing about these axioms is that it is possible to do inferences to complete the data. So for example, we can say that knows can go in both directions. So if we know that Herminio knows Mike, we can also say that the inverse relation is normally expected. So we would say that Mike knows Herminio. So now let's see an example using friend of a friend. Friend of a friend is one of the vocabularies available for modeling social relationships. And then if we see the specification, we can go here and you can see how knows the predicate knows. We will get a full explanation of this, and we are able to understand the semantics of this predicate. But most importantly, and as I said, everything is standardized and has to be machine processable. We also have a machine processable version of this specification you can see here. And this is, in fact, an ontology and can be processed by the machines, and then we can do inferences based on this ontology. But you may think that, okay, this is nice, but it's quite verbose to write. So for that, we established some prefixes, and these prefixes are commonly shared for well-known and established EHRIs. So we can make a short version of the statements that we are writing. And some of the examples are friend of a friend, that is replaced by FOV. Then we have RDF schema, which is RDFS, DBPD resources as DBR, Dublin core, that is widely used in the cultural heritage and is shortened by DC, and then records in context, that we will see more about this conceptual model and ontology further in the presentation as RICO. So if we substitute the predicate that we had before for the shorter version, we end up with this, and then we can be able to replace subject and object for shorter versions, but as they are not like commonly shared EHRIs, it will be a bit strange to shorten them for this example. So now I will hand over to Mike to follow the explanation.
Thanks, Arminio. So if we go to the next slide, you can see, so the portal is based, as I mentioned before, around standards from the International Council on Archives. And there are a lot of 4 or 5 letter acronyms here, but the big one is called the International Standard for Archival Description, and that's ISAD-G. And that essentially is a conceptual standard. So it doesn't go into the technical details of how you would sort of transmit data, but it basically describes what fields an archivist should use when they are describing a piece of material, and how these different descriptions would be structured. So you might have a description for the collection level, for example, like the whole box of stuff from a person, and then individual descriptions for each item in that box, and then together that there would be a hierarchy. So that's essentially what ISAD-G does. There were ways to sort of transmit these in across the internet, but we'll come back to those later. We also in the portal use a thing in the semantic web for modeling our controlled vocabularies. We have a few vocabularies. One of them is a list of subject headings, terms for cataloging material in the EHRI portal. And this is based on a semantic web standard called SKOS, which stands for the Simple Knowledge Organization System. And I like that because it is actually quite simple. But when it comes back to the semantic web, most of these standards are sort of 30, 40 years old for the ICA. But the ICA has actually been working for quite a while now on a new conceptual model which incorporates some of these concepts that Arminio has been talking about, particularly the graph model, unambiguous identifiers, and for objects, subjects, and predicates. And this is called records in contexts, or RIC, as I might refer to it. And this brings together the International Standard for Archival Description and the standard for archival record contexts, which is sort of for describing the people and organizations involved in how records and material have been produced. And although it was started in 2012, these things take quite a while to develop. And so the first version of Records in Context, the version 1.0 was released in, I think, January 2024 this year. So it's been in the works for a while, and it's just sort of come out in its first version. So if we go on to the next slide, this is a little bit of what RIC looks like. You can't really see the overview there, but in my very simplified version, it's quite similar to the data model we already use in the EHRI portal. We have the corporate bodies, which stands for an archival institution, which holds a record set or a collection or funds, and this includes individual records. There's one major difference in that RIC also has this concept of an instantiation, which is a conceptual separation between the record, the information that describes it, and the physical manifestation of that. So that would be a piece of microfilm or you know, a photocopy or the original material itself. So what this means, we get to the next slide, is that RIC is actually very compatible with the standards we already use. It's developed by the same people. It builds on what came before, and this means it's quite easy for us to adapt, relatively speaking. And why should we adapt to it? Well, I think it's good to recognize that new standards are building on what came before, and they're better adapted to the way people actually use them, than we may have been sort of, say, 30 years ago. In practice, we often use XML, XML versions of ISADG, particularly some of you may know the encoded archival description. And this is a way of representing an archival description as an XML document that is more machine readable. However, these things, which they first came up with in the 90s, are quite limited in the ways that we use them, and cause a lot of challenges for Arminio in particular, as a data integration specialist. So, you know, we've learned lessons in how to transmit information, and RIC incorporates some of those lessons. Personally, I believe as a consortium, we have a role to play in sort of promoting new standards and new ways to make information more accessible, and this is one of them. So if we go to the next slide, as I've mentioned before, RIC sort of unifies a number of different ICA standards: the standard for describing archival material, the standard for describing institutions that hold that material, and the so-called archival context, the people and organizations involved. But it doesn't encompass every single thing we might want to use. But fortunately, because this is a semantic web, there are a number of other vocabularies that we can incorporate. So, for example, records in context will deal with, as I mentioned before, the concept of an institution and a record and how they relate to each other. But it doesn't have every single property. It doesn't include sort of a record's postal code or something like that. But we have plenty of other options for that. So we use, for example, the schema.org, which is another semantic web controlled vocabulary, which includes a huge amount of properties for people, institutions, archives, and so on. There was also some other aspects of the EHRI Portal's data model that don't exist in existing controlled vocabularies. And for these, we can create sort of EHRI specific properties. So we start with records in context as the sort of general level that defines the structure of the data that we're dealing with, and go down to our own specific things that may be EHRI only, so to say. So on to the next slide. So this is sort of a little overview of how we actually take material that's in the portal now and create a knowledge graph from it. As I mentioned before, some of the material, the controlled vocabularies, are already in SCOS format, and that is a linked open data format, so that can just go straight into a knowledge graph. But for some of the other data, we have to do a slightly more complicated transformation. And what we do there is we use one or both of the EHRI's, the EHRI Portal's APIs. There are two APIs. One of them is for sort of simple search tasks and so on. The other is called a GraphQL API, and that's for much more detailed data retrieval. And both of those give us JSON. That's a JavaScript object notation, which is another type of way of structuring information. And from that, we go into a processor called XML, and that stands for Shape Expressions Mapping Language. We have the creator of XML, Minyo, here with us today. And if we click on that box, we can see a bit of what that actually means. So here on the left is our declarative mapping file. This shows that this takes the JSON that we get from the EHRI API and describes how we want to turn it into RDF. What Minyo's highlighted here is a web URI you can paste in that will retrieve JSON data. And if we look through that, these show how the properties from that JSON data end up as RDF triples. So this subject, predicate, object notation we've seen before. It's quite small on the screen here, but we'll share these slides later if you want to look at that in more detail. So do you want to click the convert to RDF and we can see the process? There you go. And so what we have here is that it takes JSON in. This is our mapping document and produces some nice triples out the other side that you may be able to see represent archival institutions, in particular various different properties about them in either records in context or schema.org. So if we go on to the next slide, we can see a little bit about what you can actually do with this knowledge graph. It's just a taster. So the knowledge graph is just a large number of triples that say a subject, a predicate, and an object. But we can query that using a language called Sparkle. We can see a little bit about what Sparkle looks like if we click on the Sparkle box. Is there any way we can magnify that, Minyo, so we can get it a little bit bigger? There you go. This is the simplest possible Sparkle query, pretty much, and it just selects the first 10 subject, predicates, and objects in the knowledge graph. You can see the results of that down below, and if we click on one of those, this is, you can see an IRI, and it takes us to this page, which shows us in more detail the entity in the knowledge graph and various different properties about it, which we can navigate through like this. So this is actually, no, this is a record. And if we can click the RICO is or was included in property, that takes us to a record set, I believe. And then we can see that we can navigate the graph of triples in this sort of fairly user-friendly way. I want to emphasize that this isn't sort of like the front end of a new portal, but this is just another way of looking at that information and another way of exploring this graph of triples. I think we can also go to see that graph in a more literal way if we scroll up to the top and then click on the three little dots over on the right-hand side. And that takes us to the graph view. It might take a little while to load. And there we can explore the graph in a much more graph-like way by clicking on the different nodes and viewing their properties and so on. So this is obviously something that's sort of more of interest to the more technically minded users and people who might want to use to explore this in order to build applications and different ways of viewing the data in the knowledge graph. But I think it's also quite useful just for getting an overview of the different types of material and seeing what can be possible with it. So I think if we go back to the slideshow, and I think Minyo will now talk a little bit about what we can do with this that we could not do before.
Yeah, I was planning on doing a little demo about load viewer
Okay, yeah,
live,
go for it.
but you have already covered that, so maybe I will skip that. Maybe if audience have more questions, we can come back later. So
Stealing your thunder there.
let's go into the new possibilities. So we know that technical investments are costly. So we think that this can be a pilot case for our partners in order to test these new technologies and see what the possibilities are. So in a sense, this can serve as an example, and then partners can see if they want to pursue this route. Then we are also offering the EHRI Portal's data in the new standard, so we will be able to also export the archival descriptions in this new standard, covering more open data and open access possibilities. We are also able to integrate with other similar approaches, and that's one of the key features, and also enabling a new way of querying and integrating the data. So for this last possibility, one of the main things that we have tested is answering new questions. So here we have a Sparkle query, but this is a special type of Sparkle query because this is a federated Sparkle query. So this query, what this query does is just querying two knowledge graphs at the same time. So in general, this query asks for records about people who were deported to Auschwitz. And it does that by first, with this part, querying the EHRI knowledge graph. And this other part will query the SEDEX knowledge graph. So if you think of the data that we store in the EHRI portal, we normally store only metadata about archival descriptions, but we do not store data about peoples and not about people's fate. So if we click on this, we come back to the Sparkle endpoint interface, and we are not right now running the Sparkle query against both Sparkle endpoints, both KGs, and you can see how we get the response. So if we go to one of these results, you can see here, this is one of the records that was returned. And actually what the Sparkle query was doing is just exploring these different records, then going to the subject. And we have, this is the person. And then you can see that we have an owl same as property. This is normally used for linking to other knowledge graphs. So if we follow the link, you can see that we jump to SEDEX knowledge graph. And here we have more information. I will make this a bit bigger. And apart from expanding the information about this person, we are also able to follow the persecution. So we will get more information about the persecution of this person. And then we arrive to the final result, which is Auschwitz. And we can follow this link and we get a bit more information. So this is the process that the Sparkle query was doing. And I want to show you that as we do with the web, with the semantic web, we are also able, and computers are able to also follow the links and navigate the web. And then we can also go to Wikidata and even expand more information in a third knowledge graph about Auschwitz. So you can see that this really enables a lot of new possibilities for machine processability. Nevertheless, we are facing some challenges when doing this conversion. The first one is that we are using a batch update. That means that every time that we want to refresh the knowledge graph, we have to convert everything. And because of that, we have very slow conversion. So currently, it is difficult for us to provide really up-to-date data. So we will investigate in new ways of maybe putting a streaming platform in the middle between the EHRI portal and the EHRI knowledge graph in order not to have to reconstruct the whole knowledge graph each time. And then we have another set of challenges. that are more about semantic incompatibilities with our domain model. The main one I will say is the copy linking, because records in context normally states that the copies must be between two records. And in the EHRI portal, we also allow that, but we also allow to do links between a record and an archival institution or between two archival institutions, and that is not reflected in records in context. So this is something that we will explore if it will be possible in future versions of records in context. And if not, maybe we will include that in our own EHRI ontology in the future. And then we see that this dichotomy between record resource and instantation entails some verbosity in our data. Is not really a technical challenge, I will say. But the problem is that coming from the old standards, we think that this might be a bit difficult for a lot of non-expert people to understand this duality between these two entities. So while we are following that, we will see if in the future we can offer some kind of simplification, or if we can propose to the people in records in context to search for some other ways of representing this, or new ways of doing that, because we think that is not the most usable representation. Also because in some cases we are also duplicating some of the data, so it's not a really good solution, I will say. But as it is written in the slides, newer versions might solve this issue, so we will follow that closely. And then what I think is even more important is that this opens a new vision for the future of EHRI and the EHRI portal. So right now, as Mike explained, we are aggregating a lot of data in the EHRI portal. It's very time consuming, it's very complex, it's very difficult. And the thing is that we think that the EHRI portal can transition from an aggregator to an authority hub. And now I'm going to explain a little bit more on this vision. So right now we have an aggregator, which follows a centralized approach in which the partners provide the data. And then EHRI contextualize the data, for example, with the copy linking. But the problem is that the data providers cannot easily reuse this data. So this is not good for agents access. Agents access is the same as machine processability, and it is not good for data reusability by our partners. Then on the other side, we have the federated approach in which the partners will expose the data, but then who is going to establish the links, and who is going to manage the persistent and unique identifiers throughout the network, and moreover, who is gonna contextualize the data. So we have the partners in control of the data, but then we don't have contextualization nor the links and identifiers homogeneously managed throughout the network. And then we can see an in-between approach in the way of an authority hub. In this model, the partners will expose the data, EHRI will manage links and identifiers, EHRI will contextualize the data, and because of using agreed standards, partners will be more able to reuse this data. So we will have the partners in control of their data. We will have the contextualization, and also the links and identifiers will be effectively managed throughout the network. So the benefits of the authority hub approach are twofold. For EHRI, it will be simplifying the data integration process. So in a sense, I want to kill my own job. That's kind of the conclusion. Then potentially we will be offering more detailed information. So that's better for the users, as we will see. And at the end of the day, it will allow us to better fulfill our mission. That's the end goal of EHRI. And for users, they will have more information to explore. The information will be more up-to-date because alleviating of the data integration process, and the content will be directly provided by the source, so entailing a new trust in the data that we are offering. So if you want to read more about this approach and this vision, we have published this conference paper last year in the International Semantic Web Conference in Greece. And you can follow the QR code or link in the DOI, and you can read more about all the things that we have presented here. And now I want to share some take-home messages. So the semantic web and records in context open up new possibilities for cultural heritage and EHRI, but as we have seen, they are difficult to adopt. And so we want to offer this for the partners to explore and test these new technologies. Nevertheless, this will need for a paradigm shift to realize its full potential. So we need the partners to adopt these technologies in order to make this a reality. And then we see this dichotomy between aggregator and authority hub. Some people will see that as a threat, but we see that as a new opportunity for EHRI and the EHRI portal. So now we will really like to know about your take-home messages from this presentation. But before, I have one more thing to share. And what's next for the EHRI knowledge graph? So we have secured funding to make this production ready, because right now it's just in a testing mode. We will be tackling this difficult thing of offering updates of the knowledge graph from the EHRI portal. So this is in the proposal, and we will be exploring the linking with more external knowledge graphs, like exploring more integration with SEDEX knowledge graph, but also with Wikidata, DBpedia, and much more. So this is funded by OSCARS, which stands for the Open Science Cluster Action for Research and Society, and they want to promote open science practices throughout the scientific fields. If you want to see more, you can follow this QR code, or you can click directly in the QR code to follow the link. So now we will be open to your questions, and also if you want to share your take-home messages, we will be glad to hear that.
Thank you very much, Herminio. Thank you very much, Mike, for this very interesting and inspiring presentation. We will now stop recording, and this is